to that. That is, if you haven't been to any of the lab sessions so far this week. Okay? Now, I'd like to begin, as usual, by summarizing what I did on Monday. Right? On Monday, I talked about the properties of Mlas for one parameter. And these are 4 properties. The first property is that the Mla is always asymptotically unbiased. The second property is that the Mla is always consistent. The third property is that this approaches a normal variable as n approaches infinity. And the fourth property is that if g is a one-to-one function and g of theta hat is a Mla of g of theta, provided theta hat is a Mla of theta. Shh! You guys listen, please. I'm disappointed with the number of people turning up for classes. I would appreciate if you could ask more of your friends to turn up, you know. All right, so this is... Okay, now then I talked about 2-parameter Mla. The 2-parameter Mla will not be examined, but is stuff that that you will encounter when you move to second year. There's a course in the second year called Statistical Methods, right? And you will talk about 2-parameter and multi-parameter Mlas in that course, right? But as far as this course is concerned, this is additional material which will not be examined, right? So I talked about the continuous case and the discrete case. In the continuous case, the procedure for finding the Mlas is a 4-step procedure. The first step is to write down the likelihood. The second step is to take the log likelihood. And the third step is to take the partial derivatives with respect to the 2 parameters, theta 1 and theta 2, and set them to be 0. So you have 2 equations, 1 and 2. And you solve these equations for theta 1 and theta 2. And let the solutions be theta 1 hat and theta 2 hat, right? And the final step is that if this guy here is positive and this guy is negative, then the solutions theta 1 hat and theta 2 hat are the Mlas for theta 1 and theta 2 respectively. Okay? So that's in the continuous case. The discrete case is similar. The only difference is that you have the PMF in place of the PDF, right? So this is the PMF replaces the PDF, right? Then I did one example. The example was that the data comes from a normal distribution which has, as you know, 2 parameters, mu and sigma. So the first step was to write down the likelihood function. The second step is to take the log, which is this. And the third step is to find the partial derivative with respect to mu, which gives you this, right? And the partial derivative with respect to sigma, which gives you this. So you have 2 equations, 1 and 2. From equation 1, you can find the solution for mu, which I call mu hat, to be equal to x bar, the sample mean. And from equation 2, you can find the solution for sigma squared as this one, right? So that's step number 3. Now step number 4 is to show the 2 conditions are satisfied. So to do that, you need to find the second order derivatives. So this is the second order derivative with respect to mu, the second order derivative with respect to sigma, and this is the mixed derivative with respect to mu and sigma, right? And you got them, and if you work them out at the, if you work out the second order derivatives at mu hat and sigma hat, this is what you get. This is for the first one, This is for the second order derivative with respect to sigma, and the mixed derivative becomes equal to 0, right? So this is summarized here. These are the three things you need, right? The second order derivative with respect to mu, right? Mu hat, sigma hat squared, and mu hat and sigma hat, right? And then you check the two conditions. These are the two conditions we checked on Monday, and both the conditions are satisfied. And hence the conclusion is that mu hat and sigma hat squared are the MLEs for mu and sigma, right? So I should say sigma squared here, sorry. Okay, the MLEs for mu and sigma squared. So that was the conclusion. Right, so that's what we did on Monday this week. Now, I started example 2 on Monday, and I asked you to finish this, guys. Did you have time or not? Don't tell me you don't have time. You didn't have time? So this is the likelihood function, right? This is the log likelihood function, and these are the partial derivatives with respect to mu and sigma, right? Okay, now let's see how we can do it. So equation 1 implies the following. Right, this is equation 1. Now, can you tell me, I know all of you guys are experts in calculus, I believe. I mean, you had a full semester course in calculus in semester 1, so you probably know better than me. What is the partial derivative of this with respect to mu? Do you know or no? You must have done this in your calculus course. Yes? Come on, guys. Wake up. Wake up, guys. You should have a partial derivative of y. What's the derivative of the absolute value of y with respect to y? Do you know? No? You didn't learn this in calculus? Yes? No, it's not 1. Any other answers? I want to know the answers, or possible answers you have. Plus or minus 1. But why is that? You cannot have 2 answers. You can only have 1 answer. Any other answers? Right? You didn't see, okay, the derivative of the absolute value of y with respect to y is equal to the sine of y, where sine of y is plus 1 if y is positive, minus 1 if y is negative, and 0 if y is 0, right? Okay. So what you have is the following. You have the sum I from 1 to n of the sine of xi minus mu equal to 0. Okay? This is what you have, right? Now, I know this is too much. Maybe I'm not supposed to ask you this, because the solution for this equation is, it can be proved that, I don't want, you're not expected to know this. The solution for this equation is the following. It can be proved mathematically, but it can be proved mathematically that the solution for this equation is that mu equal to the median of x. You know what the median is. We talked about it a long time ago, right? Okay. So that is equation 1. Now, let me put this here. Okay. Now, from equation 2, this is equation 2 is over here, implies that right? Okay, equation 2 implies this. So if you solve this equation for sigma, this is what you get, right? So this, you can write it like this, right? So we have solved the two equations. The solution for equation 1 is the median, and the solution for equation 2 is this guy here, right? So we are done with step 3. Now step 4 is to show that the two conditions are satisfied. So you need to show that we need to show that these two conditions are satisfied, right? Now, if I start doing it, it will take me the whole day. So what I'm going to do is I'm going to ask you to do it. right? Okay, when you have time, I'm sure you guys have plenty of time, right? Or is it not? Yeah. When you have time, try to show that these two conditions are satisfied. Yeah? Okay? All right, so that's example 2, guys. Now, the next example I'm going to do, so example 2, example example 3, right? Example 3 is this, right? That you have a random sample from ln. Ln is the log normal distribution with parameters mu and sigma squared. We want to find the MLEs of mu and sigma, right? I'm sure you guys have seen the log normal, right? Oh yeah, yes. Okay, so the first thing to do is to write down the likelihood function, which will be which is this, right? And I mean, it is important, but I've been looking at some of the quizzes you've been handing in for quiz 7. It is really important that you do get the algebra correct. You know what I'm saying when I say algebra? Like for the products of, when you deal with manipulations of products and the manipulations of sums, I'm sure I've seen teaching second year courses for the past 10 years that many students make mistakes. And that is exactly why I gave you the identities a week ago or something. Do you remember the identities I gave you some time ago? So try to follow those identities when you do the manipulations of products and the manipulations of sums, right? Okay? All right, so this is the simplified form of the likelihood function, right? Okay. So, but then you take the log of the likelihood, right? So when you take the log, This is what you get. Okay, this is the log likelihood. Okay, let's put this over here. Now, next, that's step 2. Step 3 is to find the partial derivatives, right? First, with respect to mu. Okay. So if you do the partial derivative with respect to mu, you get right, this is what you get. Okay, and simplify this to it simplifies to this, right? And this simplifies to this. And set this to 0. Let's call this equation 1, right? And so this is the partial derivative with respect to mu, and that the next one is with respect to sigma, right? All right. So you get minus n over sigma plus all right, and you set this to 0 and call this equation 2, right? Okay, now from equation 1, you can see that the solution for mu, let's say mu hat, is equal to this, right? Okay, and from equation 2, you can see that the solution for sigma squared is this, right? So these are the solutions for mu and sigma squared. So we are done with step 3. So let's put it over here. And now the final step is step 4. Right, we need to show that these two conditions are satisfied, right? once again, if I try to do this now, it will take me forever. I mean, okay, so I would like you to right, please, when you have time, all right, just to give you some exercises. I mean, but once again, please note that this material will not be examined, so you don't have to do it unless, but if you do it, it will help you with the second year material that you will do, right? So it's up to you whether you want to do it or not, okay? Right, the next one, so that's example 3. Example 4, you guys okay? Yeah? Example 4 is a little different, right? Suppose okay, so here, this question is a little different from the 3 previous examples we did, because here we have two random samples. The first random sample is from a normal distribution with mean equal to A plus B, variance equal to 1. The second random sample is from a normal distribution with mean equal to A minus B and variance equal to 1. And the 2 random samples are independent of each other. And we want to find the MLE for A and B, right? So it works like this. The first thing is that you need to write down the likelihood function for A, right? So because we have 2 independent random samples, the likelihood function will be the likelihood function for the first random sample multiplied by the likelihood function for the second random sample. This is what I mean. When I say that, this is what I'm saying. Let me write it down just to make it clear. Right? Okay, so you can see that this guy here is the the first sample. And this guy here is the right. So you see what I've written. So you have two parts. The first part is the product of the likelihood function for the first random sample. The second part is the likelihood function for the second random sample. And the likelihood is the product of the two. So this multiplied by this, right, is the likelihood. Okay? You guys okay or not? Okay? So if you simplify it, so we are still in step 1. So if you simplify this, you get right, this is what you get. You should simplify it, okay? And you can actually further simplify this as follows. Right? So this is the simplified form of the likelihood function, right? The next, so that's step 1. Next step is step 2. Step 2 is to take the log of the likelihood function. So you take the log you get the following. All right? So this is the log of the likelihood function, right? So let me put this over here. You can see this, right? Now, step 3 is to find the partial derivatives with respect to A and with respect to B. So let's first do the partial derivative with respect to A. Right, this is where your calculus comes in, right? I'm sure all of you know better than I do, right? If you do the partial derivative with respect to A, you get this, right? minus this, right? Okay, guys. So let's try to simplify this. This will be the sum of xi minus the sum of yi, right? Minus m plus, sorry, what am I saying? So it should be n, excuse me, it should be n minus m times a, right? And then here you have m plus n times b, right? This is, correct me if I'm wrong, but this is what I'm getting, right? So this is the simplified form of the partial derivative, and this is we are setting this equal to 0, right? And call this equation 1. Now the partial derivative with respect to b, right, is as follows. Did I do this correct? Just a minute. Just a minute. Give me a sec, guys. Minus plus minus. Oh, I think this should be a plus, right? This should be a plus, guys. Sorry, I'm being stupid today. I don't know why. So this should be a plus. So that means this will be a plus. This will be a plus, and this will be n minus m, right, over here, okay? And here you have minus plus, and then you have minus I apologize for this mistake, guys. Sorry. All right. This is what you get. And you simplify this, you get right. Then you have minus okay, and set this to 0, you have equation 2. Right, so you have equation 1 and equation 2, right? So let's, excuse me, sorry, which one? You mean this one? This one? Here? You mean this one is wrong? Sorry. What am I doing? And this should be plus. Okay, thank you. Is that right? Okay, thank you. Okay. I apologize one more time for the mistakes. So now from equation 1, you can see that you can see that n plus m times a minus n minus m times b is equal to this, right? And let's call this equation 3. And from equation 2, you can see that from equation 2, you can see the following. You can see that m minus n times a plus right, this is what you get from 3. And now you have two equations, and there are two unknowns. The unknowns are a and b, right? So you need to solve these two equations for the unknowns a and b. And I'm sure you know how to do, right? I mean, you've done manipulations like this before, I'm sure. So let me help you. If you multiply equation 3 by 3, right? You should multiply equation 3 by this, right? And you should multiply equation 4 by this, right? And you subtract one from the other, you will get the following. You get just be patient with me. Don't start packing yet. Okay? Trying to help you guys. Okay, this is what you get, right? So this implies that the solution for B, or what you call B hat, right, is simply the RHS. RHS stands for the right-hand side, divided by okay. So this is the solution for B, right? Okay, and once you find the solution for B, do you guys follow me or not? Right. I mean, this is simple algebraic manipulation. There's nothing more to it, right? Okay, once you find B hat, you can come from A hat. Sorry, from equation. So call this equation 5, right? Substituting right, if you substitute 5 into 4, you get m minus n a equal to sum of xi minus sum of yi minus m plus n b hat, right? So this implies that A hat is equal to 1 divided by m minus n multiplied by right. This is the solution for A, and this is the solution for B, right? So we are done with step 3, although it took a long time. Now step 4 is to show in step 4 you need to show that that the following holds. All right? You need to show that these two conditions hold, right? And once again, if I start doing this, it will take me forever. So once again, if you have time, you don't have to do this because this material, once again, this material is not examinable, or will not be examinable, right? Right, so I managed to do only 4 examples, but not the 10 I promised, right? But next week, just before you go, right, next week, the topic for next week will be confidence intervals, right? So we are done with maximum likelihood estimation, right? So the topic for... Now, once again, if you have done week quiz 7, can you please hand it to me? sir. You okay?